In this video, we will cover our exploratory data analysis. The goal of our exploratory data analysis is to gain a better understanding of our data so that we can interpret the results of our modeling work in the future better, and so that we can understand some of the steps that we will need to take in our data cleaning and future engineering steps in the next videos. In this workflow, we are first loading in the dataset on the left-hand side, and then we are building visualizations by filtering using our SQL nodes and then graphing using our graph values nodes. Here on the right side, we are doing a similar thing. Each of these sections follows approximately the same function. They take the data and filter it using the SQL node, and then we add row indexes using the node row by filter by index, and then we graph the values associated with each filter. Now let's take a look at some of the visualizations that we've created. The first graph we created was the number of store where a product is sold. This essentially tells us how products are stocked, or how widely they are stocked among our stores. For example, we can see that product number 110 is stocked in 10 different stores. This is an outlier, and it may be useful in the future to keep track of this product number so that we can explore it further. Here we have the store ID versus the count of 0 sale days. 0 sale days are an important metric for on-shelf availability, as products that are not being sold regularly should be stocked less often. And we want to ensure that we also are maintaining the same pace of stocking for our items. Next, we have the 0 sales day, but instead of by product, by store. Here we have combined all of the stores, and we have taken the product numbers and the number of 0 sales days in each and aggregating them for this visualization. Looking at product number 110, as we did before, we can see that it has a very high number of 0 sale days, 678 in this case. This tells us that while it has been stocked in many stores, it often experiences 0 sale days. It may be useful in the future to keep track of this and to ensure that product 110 is either stocked less often in the stores or that it is stocked in fewer stores. Here we have the sum of total sales for the units of each of all products, split up by store ID. This is essentially telling us the overall performance of each store, calculated as the total number of sales of the units, not by revenue, but by the number of units sold. Here we have the sum of all total sales for every product in every store. For example, if we look at product 110, we can see that we had 12,008 sales of this product across all of our stores. While it is both the most widely stocked product, it is not the best-selling product. We can see that product number 2 has a greater number of sales across our stores. This is something to keep in mind in the future, and we may want to look at the option of stocking product number 2 more often or in more stores. Now that we have an understanding of our data, we can move on to our next steps, specifically our feature engineering and data cleaning steps. We will cover those in the next video. Thank you for listening.